Hello children, we are doing calculus. In that from the first topic limits will do, derivatives and integration later will come in. So based on the concept of limit, we are writing. For getting the concept of limit, we are considering a function f of x equal to x squared minus 1 by x minus 1. So in this one, when you will take f of 1, that means when you will substitute x equal to 1. When you will substitute x equal to 1, what will happen to x equal to 1? When you will substitute x equal to 1, what will happen to f of x? F of 1 will be equal to, we are substituting in this equation. It will become 1 square minus 1 divided by 1 minus 1. 1 squared is 1 itself. So 1 minus 1 will be 0. So 1 minus 1 will be 0. As once one I will just write 1 minus 1 divided by 1 minus 1. It will become 0 by 0. It will be 0 by 0. So we are writing that is clearly f of 1 equal to 0 by 0, which is meaningless. So it is meaningless. So if it is meaningless, then we can say that f of x is not defined at x of 1. So for getting a proper definition for that one, what we will do, again f of x equal to x squared minus 1 by x minus 1 will take, and we'll check that one whether it is factorizable. We can factorize the numerator by using the identity a squared minus b squared actually. So here x squared minus 1 squared, I'll write here x squared minus 1 squared can be factorized by using the identity a squared minus b squared. A squared minus b squared identity is a minus b into a plus b. So we'll write x squared minus 1 squared as x squared minus 1 squared as x minus 1 into x plus 1. So we wrote that one as x squared minus 1 squared as x minus 1 by x plus 1 divided by x minus 1. We can cancel the numerator x minus 1 and denominator x minus 1. Now denominator is free from the x term actually. So even if we'll substitute 1 in the denominator, this numerator and denominator will be cancelled. So there is nothing to substitute in the denominator. If we'll substitute anything in the denominator, 1 minus 1 in the number by 0 is not defined actually. So that is why we are trying to remove the denominator. So here x minus 1 and x minus 1 will be cancelled. We'll get x plus 1. And then this condition is satisfied only when x not equal to 1. Because if x equal to 1, if x is equal to 1, then x minus 1 will be 0. Any number by 0 is not defined. I'll just write that one. If x equal to 1, then x minus 1 equal to 0. 1 minus 1 equal to 0. If we substitute in the first equation, it will become any number by 0. Any number by 0 is not defined. So we will not select that value. So we will write the condition only when x not equal to 1. Now we will write if we go to x, a value not exactly 1, but slightly more than 1. So now we are substituting the value of x slightly more than 1. Then clearly the value of x is slightly more than 2. We took one example. If x is a value slightly more than 1. So here we are taking not exactly 1 but slightly more than 1. So we took a value 1.1. So f of x will be 2.1. How you got? Because f of x equal to x plus 1 equal to 1 plus 1.1, which is equal to 2.1. From there we are getting the value 2.1. Similarly, when you substitute for f of x equal to 1.01, f of x will be again 1 plus, I'll give the equation number 1 here. So equation number 1 will become f of x equal to 1 plus 1.01, which is equal to 2.01. In the same way, again we'll write that is x equal to, I'll just write x equal to 1.01. So equation number 1 will become f of 1.01 will be equal to 1 plus x plus 1 it is, that is x plus 1, which is equal to 1.01 plus 1 equal to 2.01. In the same way again, if x equal to 1.001, what happened? If we go on decreasing this value and take it nearer to 1, then clearly the value of f of x will come near to 2. So we are proving that one. So if x equal to 1.001, then we'll write f of 1.001. That will be equal to, again, x plus 1, which is equal to 1.001 plus 1 equal to 2.001. We'll keep on doing like that, and we took a value very closer to 1 now. We'll keep on decreasing the value, and now it became very closer to 1. So when you add that on, f of 6 zeros and 1 will be f of x equal to, that is 2.00001. 6 zeros and 1. That much you'll get, because we'll add 1 to this place. Now here next one, thus as the value of x approaches 1, the value of f of x approaches to 2. So when x is approaching 1, f of x is approaching 2. So we'll say that when x tends to 1, f of x tends to 2 also, or approaches 2. Similarly, if we'll give to x a value slightly less than 1, then the value of f of x will be slightly less than 2. Now, in the same way, now we are taking a value of x slightly less than 1. So when x is slightly less than 1, that is 0.9, then f of x will be 1.9. How we got that one? In the equation number 1, when you substitute, f of x equal to x plus 1 is equation number 1. And now here we are writing f of 0.9. F of 0.9 will be, actually, I'll just write x plus 1 equal to 0.9 plus 1 equal to, you will get 1.9. Now, if x is equal to 0.99, which is a value less than 1, f of x will be 1.99 from equation 1, because from 1 actually, you know that f of x equal to x plus 1, actually, x plus 1, and you will do x plus 1, that is 1, x is 0.99 plus 1, and you will do 0.99 plus 1. So 1.00, 0.99, and you will add, you will get you'll get the value 1.99. That is the value. So you'll get the value 1.99. Now we'll keep on increasing the value and bring the values closer to. Keep on increasing the value of x and bring the values of x closer to 1. When you bring the values of x closer to 1, that is 0.999, at that time you will get f of x equal to 1.999. That means 999. That means it will be closer to 2. So like that, again some more values, so it will become very closer to 2. And thus in this case, as x tends to 1, f of x tends to 2, or approaches to 1, f of x approaches to 2. Now in this case, we can express these factors when limit x tends to 1. That means x is approximately equal to 1, f of x, that time limit x tends to 1, x squared minus 1 by x minus 1 is 2. How it will become 2? So I'll write in the plain form, limit x tends to 1, f of x equal to limit x tends to 1, x squared minus 1 by x minus 1. We did the splitting of term according to the identity, a squared minus b squared. So it will be limit x tends to 1, x plus 1 into x minus 1 divided by x minus 1. So that denominator and numerator x minus 1 got cancelled, and you will get limit x tends to 1, x plus 1. And you will substitute that value of x, you will get 1 plus 1 equal to 2. From there, we are getting this value 2. Now, limit. So, we say that in general, when limit x tends to or approaches to a, f of x will tend to 1. F of x will tend to 1. So, that is, whenever x tends to a, f of x will be tending to 1 only. Now, here, working rule for finding limit x tends to or approaches to a, f of x. So, rule 1. Put x equal to a in the given function. A can be any constants actually. So if f of a is a definite value, then limit x tends to a or approaches to a, f of x will be equal to f of a. That means we are replacing x by a. We wrote one example, limit x tends to 0 sin x equal to, I am substituting the value of x as 0 actually, because they taught when x tends to 0. So it will become sin 0. But you will know that one, sin 0's value is 0. So we'll get a definite value 0. Now next one, limit x tends to 1, x squared plus 5x plus 2, that will be equal to, now we are substituting the value, equal to, I am writing 1 squared plus 5 into 1 plus 2. So 1 squared is 1, 5 into 1 is 5 plus 2. That is 5 plus 2 is 7 plus 1, 8. So you got a definite value. If you are not getting a definite value, at that time we will go to next rule. Now if f of a is indeterminate, then we adopt the following rules. So rule 2, if f of x is a rational function, then factorize the numerator. That means if the numerator is factorizable, we should do the factorization either by identity or by splitting of middle term. Then factorize the numerator and the denominator. Cancel out the common factor and then put x equal to a. So we are doing one example, evaluate. Limit x tends to 3, x t and ds tends to 3, x squared minus 9 by x minus 3. In this case, we will not substitute the value of x directly as 3. Because if we substitute the value of x as 3, it will become 3 minus 3. 3 minus 3 will be 0. Any number by 0 is not defined. So any number by 0, in general I will write any number divided by 0 is not defined. Wait. Now we will do the example, evaluate. Limit x tends to 3, x squared minus 9 by x minus 3. If we will substitute directly for x as 3, it will become 3 minus 3. 3 minus 3 will be 0. So in the denominator, if you will get 0, any number by 0 is not defined actually. So we'll factorize the numerator. So in the answer part, we'll write limit x tends to 3, x squared minus 9 by x minus 3. We'll split x squared minus 9 as limit x tends to 3, x squared minus 3 squared divided by x minus 3. Now this numerator is of the form a squared minus b squared. Numerator is of the form a squared minus b squared. So we'll apply the identity a minus b into a plus b. We'll apply the identity a minus b into a plus b. Here a will be x and b will be 3. So we'll substitute that value now. So it will be equal to limit x tends to 3, which is equal to limit x tends to 3, x minus 3 into x plus 3 divided by x minus 3. So that now you can cancel the denominator x minus 3. X minus 3 in the denominator and x minus 3 in the numerator will be cancelled. The term left out will be limit x tends to 3, x plus 3. Now you can substitute. Now denominator became free from x minus 3. Now we can substitute the value of x as 3. So we will get 3 plus 3 equal to 6. Now we will go to example 2. Second example. It will be limit x tends to 1, x tends to 1, x squared minus 4x plus 3 divided by x minus 1. In this case also, since the limit is x tends to 1, in the case of instead of x, if you substitute 1, it will become 1 minus 1, 0. Again, you will get not defined, any number by 0 not defined. For avoiding that one, we will do the splitting of middle term in the numerator and we'll check whether we can cancel the numerator and the denominator. So we'll do the factorization of x squared minus 4x plus 3 I'll do first. So on multiplication you need the coefficient of x squared into constant. Coefficient of x squared will multiply with the constant. So when you multiply coefficient of x squared with the constant on product, that means product should be a into b, which is equal to 1 into 3. 1 into 3 is plus 3 here. 1 into plus 3 is plus 3. And sum will be the term with the coefficient of x. So coefficient of x is the sum actually. A plus b equal to minus 4. Now we'll do the prime factorization for 3. We'll check which all factors will give us minus 4. So 3 ones are 3. We need minus 4. So minus 3 plus minus 1 will give you minus 4. We are confirming that one once more. Here it will be minus 3 into minus 1. Will be plus 3. Now we'll write that one as 1x squared minus 4x will write as 3x minus 1x plus 3. Now we'll take the first two terms and the last two terms. In the first two terms, x is the common number, common variable. When you take from x squared x outside, 1x will be left and minus 3. For the second set of terms, there is no common factor. We'll take minus 1 outside. So minus 1x will change into plus 1x and plus 3 will change into minus 3. Now x minus 3 is a common factor. We'll take x minus 3 common outside. The term left out will be x minus 1. These are the factorization answer for x squared minus 4x plus 3. Now I'll write the real question. That is limit x tends to 1, x squared minus 4x plus 3 divided by x minus 1. Now in this case, after splitting the term, you'll get limit x tends to 1, x minus 3 into x minus 1, x minus 3 into x minus 1 divided by x minus 1. Why we are doing the splitting of middle term? For cancelling the numerator and denominator, so that when you substitute the value of x as 1, at that time, that means a as 1, at that time there should not be any 0 in the denominator. So we'll write now x minus 1 in the numerator and in the denominator will be cancelled. So it will be equal to limit x tends to 1, x minus 3. Now we are able to substitute the value of 1, that is a. So it will be in the place of x, now we'll write 1 minus 3. At that time, we will not write the limit. So equal to minus 2. We got a proper answer for that one. Now we'll go to next type of question. Now we'll do rule 3. If the given function contains a surd, that means the terms with root sign, then simplify it by using a conjugate surd. Conjugate side means the term with this middle sign you should change. This minus sign should become plus. Opposite sign should be. After then simplification, put x equal to a. So we are writing now here in this one. Evaluate limit x t and s tends to 0. Root of 1 plus x minus root of 1 minus x divided by x. So that will be equal to, now we are starting the answer. If you substitute directly x equal to 0 in the denominator, any number by 0 again we will get not defined, which is not possible. So now we will write limit x tends to 0. Root of 1 plus x minus root of 1 minus x divided by x. That is the question. Now we will multiply numerator and denominator by, this is multiply numerator and denominator by opposite sign of this root term, that is third. So by root of 1 plus x, middle sign will change, plus root of 1 minus x. So it will be equal to limit x tends to 0, root of 1 plus x minus root of 1 minus x whole divided by x into again root of 1 plus x plus root of 1 minus x divided by root of 1 plus x plus root of 1 minus x. Now we will multiply the numerator terms. Numerator terms are of the form a minus b into a plus b. I will write the identity a minus b into a plus b. Numerator is of the form a minus b into a plus b. So identity will be a squared minus b squared. Here a is root of 1 plus x and b is root of 1 minus x. It's an identity actually. Now we will multiply the numerator. So answer will be root of a squared minus, not root of, limit x tends to 0. Root of 1 plus x, a squared I am writing, whole squared minus root of 1 minus x, the whole squared. So a squared minus b squared divided by this denominator full will write like that, x into root of 1 plus x plus root of 1 minus x. Now here root of x the whole squared will be equal to root x into root x. Directly you can by heart as x. So it will be equal to limit x tends to 0, root of 1 plus x the whole squared will be 1 plus x minus, since there is a minus sign, after the minus sign you put a bracket, 1 minus x whole divided by x into root of 1 plus x plus root of 1 minus x. Now we'll open the bracket. It will be limit x tends to 0, 1 plus x minus 1 plus x divided by x into root of 1 plus x plus root of 1 minus x. Now minus 1 and plus 1 will be cancelled. When you cancel minus 1 and plus 1, you will get the term x plus x, that is 2x. So it will be limit x tends to 0, x plus x will be 2x divided by x into root of 1 plus x plus root of 1 minus x. Now x in the numerator and x in the denominator you can cancel. Now x in the numerator and x in the denominator will be cancelled. So term left out will be limit x tends to 0, 2 divided by root of 1 plus x plus root of 1 minus x. Now if you substitute x equal to 0 in the denominator, there will not be any finite denominator as 0 will not get. So we'll substitute for x 0 now. That means when x tends to a, f of x we are finding. So 2 divided by 1 plus 0 root of 1 plus 0 root of 1 plus 0 plus root of 1 minus 0. So that will be equal to 2 divided by root of 1 plus root of 1. Root of 1 is 1 only, 2 by 1 plus 1, because root 1 is 1, square root of 1 is 1 only. So equal to 2 by 2 equal to 1. That is the answer. Now we'll go to rule 4.